Welcome to another edition of CSEC Chemistry Simplified. In this lesson, we will be looking at alkalinity, acidity, and the pH scale. Once again, I am Sir Damien LaRose. In this lesson, we will be focusing on the dissociation of water, understanding acidity and alkalinity, the pH scale, and strength of acids and bases. Now to look at the dissociation of water. Water, when it dissociates, produces hydrogen ion and the hydroxide ion according to the equation that we will be looking at below. There we have water being H2O, and when it dissociates, it goes to have H plus OH minus. Remember previously, as we begin to look at acids, bases, and salts, the H plus gives us the acidic nature, while the OH minus gives us the alkaline nature. So there we have it, H plus being the acid component and OH minus giving us the alkaline component. To begin with, we must remember that water is neutral. When it dissociates, it produces 1 mole of H plus ions and 1 mole of OH minus ions as being neutral. When we think of neutral, it means that there is equal quantity of H plus ions and OH minus ions present. There is no H plus ions or OH minus ions present, or any species that can cause the environment to become acidic or alkaline spontaneously. Note, the environment must be aqueous. As we begin to understand acidity and alkalinity, first, when we speak of acidity, if a substance is added to water that causes the H plus ion concentration to increase, that substance is considered to be acidic. Going back to what we just learned, is that there are equal quantities of H plus ions and equal quantities of OH minus ions, and therefore they would cancel out each other, making the environment neutral. Now when a substance is added to water that increases the H plus ions, therefore we would say that that substance would be considered to be acidic, because the H plus component is acidic. And to test using litmus paper, we would see that an acidic environment would cause blue litmus paper to turn red. That is how we can determine whether an environment is acidic or not. Alkalinity: if a substance is added to water that causes the OH minus ion concentration to increase, that substance is considered to be alkaline. And again, if we should go back to water, which produces equal quantities of the OH minus ions and the H plus ions, because they are equal in quantity, they would cancel out each other. It doesn't mean that there isn't any acidic component or alkaline component. It simply means that because the quantities are equal, they cancel each other, and so the environment appears neutral. And therefore, when a substance is added that produces OH minus ions or cause the OH minus ions concentration to increase, we would consider that substance to be alkaline. And to test if the environment is alkaline, we use red litmus paper. And so if an environment is alkaline, it causes the red litmus paper to change to blue. This is a simple test to determine whether the solution or the environment is alkaline. Solutions of acids and alkalis can vary widely in their acidity and alkalinity. It is useful to know not just whether a solution is an acid or whether it is an alkali, but how acidic or how alkaline it is. To measure acidity and alkalinity, we can use the pH scale. Here we'll be looking at the pH scale. The pH scale is a scale developed to measure the acidity or alkalinity of a substance. The color indicates the level of acidity or alkalinity in that substance. And what we need to note is that the scale ranges from 0 to 14. If we should examine the different sides, that is the right and the left, right being alkali and the left being acidic, notice that the colors change gradually, and then we have 7 being neutral with green. Notice from 7 to 0, there would be an increase in acidity, and there is a gradual change in color from green going to red. For the alkali side, you will also notice that there is a gradual change in color from 7, where it is neutral, to dark purple, or we would say violet. The gradual change indicates that there is an increase in strength of the acidic nature or the alkaline nature of the substance. So when we use certain substances, for instance, we can use acidity or alkalinity of a substance. Previously, we have used pH paper. That is litmus paper. Litmus paper would only indicate that the substance is either acidic or that the substance is alkaline. It would not indicate whether the substance has a pH, say, of 1, 2, or 3, or if it has a pH of 11, 12, or 13. The larger number on the left-hand side would indicate that we have a stronger alkali, whereas the smaller number on the left-hand side would tell us that we have a stronger acid. And so we can find acids such as hydrochloric acid and sulfuric acid around 1 and 2. And we can have 13 and 14. We can find bases or alkalis such as sodium hydroxide and potassium hydroxide. So continuing with the pH scale, we can use universal indicator solution or paper, and that would be able to give us the pH of the solution. It would tell us exactly how strong of an acid there is, or how strong of an alkali there is, or whether it is neutral. Notice that the pH paper is yellowish in color, and based on the pH of the solution, it would give us a different color. Say, for instance, if there should be a strong acid, it would indicate when it is placed in that solution, it would turn to red or dark red. If the acid is weak, it may remain as the same yellow, or it can give an orange color. For neutral, it will give green, and as we go up to the alkaline side, notice that it would give purple, blue, or violet. So that is how the pH paper works. Here we have the universal indicator solution. It is a liquid with various compounds in it, and it will be a dark mixture of green and orange. So sometimes when you look at it, it looks kind of greenish, or if you look at it, it looks like a dark orange. When we place a few drops of the universal indicator solution, say for instance in an acidic environment, notice that it turns pink, or it can turn red, and depending upon the strength of the alkali, it would give us a purple color. That indicates that the alkali is very strong. And then we can match it to the pH scale to say what pH it is. So here's how we can work with colors using the universal indicator solution to identify the pH of a solution. To have a better view, we have a variety of solutions with various pH using universal indicator solution to give us a better idea of how it works. Notice that we have a mini scale below where we have acid, neutral, and we have a base, those which are basic. So from left to right, notice that we have reddish pink, then we go to orange, moving up we have light yellow, yellow green, green, that is a darkish green, then we have a bright green with some blue in it, and then we get to blue. So this is how the universal indicator solution can tell us the pH of the solution. Using this scale, universal indicator solution or paper is used to determine the pH of solutions, and we can have different household chemicals, their pH to be identified. In chemistry, we consider all substances to be a chemical. In the home, we can call them food, cleaning agents, and so on. But remember, for chemistry purposes, we refer to them as a chemical. And so notice that we have neutral. We have a test tube there which indicates blood, which is just about 7.4. So blood is slightly alkaline. Also, if we go up, we notice that we have seawater with a pH of 8, a little bit more alkaline. Baking soda, pH of 9. Ammonia solution, pH of 10.5 to 11.5. And we continue to go all the way up to liquid drain cleaner, which has a pH of about 14. And if we should go to the bottom, we have a glass of milk, and that is at pH 6. So milk is slightly acidic. Coffee is at pH 5. Going down is even a little bit more acidic. Grapefruit juice, it is just between 3 and 4. Lemon, notice it is at 2, between 3 and 2. And battery acid is just between 1 and 0. So as we go down, if you have a battery in your house, knowing that we have the solar chargers, sometimes you may have a car battery, a truck battery, or one of these solar batteries, I encourage you not to play with it because it has acid that is very, very strong. We will now look at the strength of an acid or a base. The strength of an acid or a base is based on the completeness of dissociation when dissolved in water. First, we will be looking at the strength of an acid. What we need to know is that acids, when pure, are covalent compounds, generally. To give an idea, notice that we have the acid H2SO4. Sulfur is in yellow, hydrogen is in white, and oxygen is in red. So there we have it, H2SO4. So there we have sulfuric acid going to give us the sulfate ion, which is SO4, 2 minus, plus hydrogen ions. Notice that both hydrogen ions are dissociated from the sulfate group. When some of the acid dissociates into ions in a dilute solution, the acid is said to be a weak acid. Here we have the ethanoic acid going to give us ethanoate ion and hydrogen ion. Notice that the reversible sign indicates that there are both ethanoic acid and the ethanoate ion and hydrogen ion present in the mixture. And so here we would have CH3, COOH, our reversible sign. Then we have CH3, CO, O minus, plus H plus. The reversible sign indicates that there are both ethanoic acid, the ethanoate ion, and the hydrogen ion present in solution. And this would tell us that we have a weak acid, not a strong acid. Previously, we had sulfuric acid completely dissociating to give us SO4 2- and H+. We will now continue to look at the strength of an acid and a base. In this case, we will be focusing on an alkali. And so the strength of an acid or a base, remember that it is based on the completeness of dissociation when dissolved in water. Bases are generally ionic compounds except for ammonia. For instance, if we should use sodium hydroxide, that would give us Na+ and OH-. Notice that the hydroxide ion is completely separated from the sodium ion. And so we will say that sodium hydroxide is a strong base. Our key points for this lesson would be: when water is ionized, it produces hydrogen ions and hydroxide ions in equal proportions. Hydrogen ions are acidic, while hydroxide ions are alkaline. Universal indicator paper or solution is used to determine the pH of a solution. Strong acids and strong bases completely ionize, while weak acids and weak bases partially ionize. This brings us to the end of another session of CSEC Chemistry Simplified. Join us again as we look at our next lesson for acids, bases, and salts.